We are going to divide some polynomials today. So first I want to refresh your memory on how you divide numbers. So if you are dividing 562 by 5, you want to see how many times first 5 goes into your first digit of 5. It goes in once. 1 times 5 gets you 5. And then you subtract, which leaves you with 62. Then you again look at your new first digit of your result of 62 and go, hey, how many times will 5 go into 6? 1, so that becomes part of your quotient, and then you multiply 1 times 5 gets you 5, and then subtract again gets you 12, and then since 5 won't go into 1, you look at 12, and 5 will go into 12 twice. Multiply 5 times 2 gives you 10, subtract leaves you with 2, and then 2 isn't divisible by 5, so 2 is your remainder, or you can just write it as 112 and 2/5 for your results. Now when you divide polynomials, you're going to divide them the exact same way. One thing we're going to want to check is to see if any of our exponents are skipped in our expression. So if our highest degree term is x to the fourth, I want to have an x to the third, an x to the second, an x to the first, and then an x to the 0, or just a plain number without any of those powers skipped in the middle. If any of them are skipped over, in this case our x squared term is missing, there are 0 x squareds, I want to go ahead and write that in. That way my terms, when I line up to subtract in my division process, are actually like terms. You don't necessarily have to, but if you don't put in that placeholder of 0 x squared, you need to be super careful that you are only subtracting like terms. So kind of like when we divided our numbers, we looked at our first digit, we're going to look at our first term, 2x to the fourth, and see how many times x squared will go into it. So if I divide 2x to the fourth by x squared, I get 2x squared, and that's going to be the first part of my result. Kind of like I multiplied my 1 back times 5 and then subtracted, I'm going to multiply my 2x squared result back times all 3 terms that are on the outside, and then I'm going to subtract that result. So if I multiply 2x squared times x squared plus 2x plus 1, it's going to give me 2x to the fourth plus 4x to the third plus 2x squared. And then I need to subtract that whole entire result, so I'm going to go ahead and put it in parentheses and distribute my negative, change all my signs, and then add things together. If you don't want to, you don't have to. Just make sure you are super careful remembering you're subtracting, like x to the third minus 4x to the third. You don't have any x to the first or constants, so you can put zeros in for those or just drop them down, and you end up with that result. Now you need to take your new first term of negative 3x cubed and still divide it by your first term on the outside. So negative 3x cubed divided by 1x to the first gives me negative 3x, and then I kind of just repeat the process. I multiply negative 3x back times x squared plus 2x plus 1, which is going to give me negative x cubed minus 6x minus 3x. I'm subtracting all of that. So this is where I really prefer to change my signs, otherwise I have to think minus and negative on all of those. So if I do my subtraction, now addition, I'm going to end up with 4x squared plus 4x minus 1. And then guess what? You repeat it again. So you take your new first term of 4x squared and then you divide it by x squared. If you're wondering when this will end, don't worry. It is kind of a long process, but once you get the hang of it, it's not terrible, and you'll get faster. So we got 4, we multiply that back times our x squared plus 2x plus 1, and guess what? You subtract that entire quantity, which is going to give you a negative 4x minus 5. Main place people mess up at is when they're doing their subtraction with their signs, so be extra careful. Okay, we've got negative 4x for our new first term. We are going to try to divide it by x squared. But guess what? If you try to divide that by x squared, you end up with negative 4 over x. It didn't come out to be a whole number. We've got a variable in the denominator, so it's not a polynomial. That means we are actually to the point where that negative 4x minus 5 is our remainder. It doesn't divide in evenly anymore. So we'll have a remainder of negative 4x minus 5, and how you write that is your quotient plus that over what you were dividing by. Again, when I look at this one, the first thing I'm going to do is realize that there are 0 x to the first terms in there, and there's also not a constant on my divisor, so I'm going to go ahead and put zeros in for those as placeholders when I write my division problem here. So I'll have x squared minus x plus 0 on the outside. Since that's at the end, the 0 instead of in the middle, it's not quite as big of a deal. If you don't put the placeholder in, you're less likely to mess up, but I would go ahead and put it. So take your first term on the inside, divide it by your first term on the outside, you just get x. Multiply it back, gives you x cubed minus x squared plus 0x. And then you are subtracting all of that, which means change all your signs, you will end up with a 4x squared plus 0x minus 7. Repeat your process, divide 4x squared by x squared, which will give you just 4. Add that to your quotient and then multiply your 4 back. You have 4x squared minus 4x plus 0. Subtract that entire result, which is going to just give you a 4x minus 7. And then when you go to divide that new first term of 4x by x squared, it doesn't divide in evenly because you'll have a 4x over x squared, which is going to give you an x in the denominator, which means we have 4x minus 7 as our remainder. So our result's going to be x plus 4 plus 4x minus 7 all over our x squared minus x that we were dividing by.